Network operations rarely fail for lack of data. They fail because evidence is scattered across devices, scanners, tickets, and late-night manual checks. NemoFleet brings those signals into one governed control surface, moving teams from reactive firefighting to continuous observation and verifiable action. The overview answers the questions that matter first. How many devices are managed, which events policy allowed or denied, and what needs attention now? The same screen combines node health, security posture, and escalations, so operators do not have to reconstruct reality across disconnected tools. The architecture view shows a lead node receiving requests, interpreting intent, and delegating each task to a specialized worker. Operations, security, and governance run in isolated environments with clear roles. No single agent pretends to do everything. Delegation uses scope channels, keeping every request, response, and result traceable for troubleshooting and incident review. The flow view breaks a task into observable steps, from the human request and lead assignment to worker execution and final status. A deployment timeline preserves sequence and outcome, showing where work is blocked instead of exposing only a final conversational answer. The fleet view brings together worker nodes, container status, diagnostics, inference routing, and devices connected to the environment. Administrators can compare node state, apply filters, and confirm that every role is operating inside its expected scope. The security view fuses configuration drift, vulnerabilities, active scanning, certificates, and weak cryptography into an actionable posture. Each exposed item maps to an explicit hardening control. Remediation uses defined settings, target values, and verification steps rather than improvised commands. An operator can launch an active scan directly. Targets, tags, findings, and severity remain visible, while trackable issues move into the workflow. The same page unifies certificate risk, cipher policy, source analysis, software bills of materials, and vulnerable versions, keeping device and code evidence in one context. Before any action runs, it passes through a guardrail. Inputs are checked for prompt injection, privilege overreach, and unsafe intent. Recent decisions, rejection reasons, and matched rules are visible, allowing security teams to verify that unsafe requests were actually denied. Fail open and fail close states are also exposed, so protection failure cannot silently become an operational blind spot. A request that clears the guardrail still enters the decision boundary, where actions, parameters, risk levels, and approval paths are encoded as policy. Reversible low-risk fixes may run automatically. High-risk changes require human approval, while forbidden actions are rejected before they touch a device. Automation, therefore, has an explicit boundary. Models interpret intent, while programmatic policy controls authority and execution conditions. The governance view places policy events on a timeline and separates allowed, denied, and excluded heartbeat traffic, keeping metrics meaningful. Recent events can be filtered by category and policy states compared directly. Teams see not only the outcome, but the rule and reasoning behind it. After a change, the system reads device values back and compares them with the intended state. Work is complete only when the evidence agrees. The audit view records delegation, tool execution, policy decisions, and verification results as one searchable chain of activity. Integrity checks protect that chain. If a record changes, the linkage breaks visibly, so later review does not depend on trusting one database. Operators can narrow the evidence by role, worker, or action and quickly answer who did what, to which target, and when. The scorecard turns agent quality into comparable long-term measures, including completion, retries, escalations, and recent trends. These scores are operational signals, helping teams identify which role needs better policy, tooling, or task boundaries. Teams can automate more while continuously measuring whether that automation is reliable and whether quality is improving or declining. The proactive view makes scheduled patrols operational. Teams set cadence and observe signals, then trigger an immediate patrol when needed. Only genuinely new issues and state changes are escalated. Repeated events are suppressed, so on-call staff are not buried in duplicate alerts. When a person must intervene, the context is already assembled: the finding, policy decision, attempted work, and recommended next step. The administration view centralizes demo mode, emergency freeze, backup, restore, and account management in a control surface. Emergency freeze can suspend fleet actions, while backup and restore preserve governance settings for routine maintenance and incident recovery. NemoFleet connects observation, collaboration, policy, execution, and evidence in one operational loop. It moves network operations from reactive response to governed, verifiable collaboration that keeps improving.